to use the belly of the camera. Oh, that's lovely. How do I start? It says I'm off air, but it says I have 2 viewers. That's not possible. Let's just do a quick test before I get started here. No, we're rolling. Good. So hello everyone. Welcome to e-learning 3.0, the talk. And also welcome to the official launch of the e-learning 3.0 MOOC. What I'm going to be talking about today is covering the overall topics being covered in the MOOC. I'm going to be covering all kinds of stuff, but we'll be looking at that at a more leisurely pace during the MOOC. This talk is available, it's a bit hard to see, www.downs.ca/presentation/498. So the slides are up. Hopefully the video will be available as you leave this room. Everything has worked perfectly. So if you've forgotten everything immediately, you can sit down outside and watch it all over again. We are broadcasting live, hopefully, if it hasn't broken yet. So remember that. Anything that you say will be used as evidence against you because it's the internet. Right? So don't say anything you don't want your grandmother to hear or your granddaughter, depending on how old you are. So yeah, this is the launch of e-learning 3.0. It's my first MOOC in a couple of years, and it introduces a whole bunch of topics, but let me give you the quick overview to begin with. We began 20 years ago, seems like yesterday, with Web 1, or also e-learning 1.0. No problem. You're just on live internet. No, I'm just kidding. Oh, I see. It was on. I tested it before I started. Oh, well, I'll let you do your thing. So, yeah, that was the client-server model. We had websites. We would go to websites. That was the era of content management systems. And if you're using a learning management system still today, that is a legacy from that era. The idea where you had a big website, a silo, and people went to your silo. That was the era of portals and places like Yahoo, and even places like Google back in the day. Then we had e-learning 2.0. You might remember e-learning 2.0. Came on like gangbusters, 2003, 2004. That was the platform model. And what was really cool about that was that the platforms talked to each other in the background. And so we got out of that things like social networks and application programming interfaces so that you could work with multiple websites at the same time. You could load a photo in Flickr and edit it in Picnic. It was great. But it also produced Facebook, And it also produced Twitter and companies that spy on you and spies that spies on the companies that are spying on you and hacking. And of course, horrible, horrible internet advertising, and you know all the rest. Fake news. There's no stopping it. So I'm here to talk about Web 3 and related concept, e-learning 3.0. And this is a hopelessly oversimplified representation of that. You notice we've gotten rid of the platforms, we've gotten rid of the websites, and it's just individuals in a network talking to each other. Now, those individuals aren't just individuals, they're working with powerful tools, they're working with technologies that exist in the cloud and beyond. They've got the Internet of Things, they've got artificial intelligence and all of that, but mostly it's them talking directly to each other. Wow. We're done. Thank you for coming. No, there's a bit more to it than that. The course, and therefore the talk, and therefore the topic, is structured around this outline, which you cannot read in the back. Data, cloud, graph, community, identity, resources, recognition, experience, and agency. I'm going to go through each of those. It's a lot, so I'm not going to linger. I'd love to linger, but I promised them I'd leave room for questions at the end, and I'm really going to try. But again, remember, there's a recording of this session. You can go back and watch it later. You can get the slides. You can take the course. You don't have to sign up for the course, by the way. I don't do sign-ups for my course because I think they're silly and authoritarian. All you have to do to take the course is go to the course. There is a newsletter. If you want the newsletter, you have to give me your email address because otherwise I won't know where to send the newsletter. But that's all I want. I don't want your name. I don't want your address, your cat's paw size, whatever. Because what would I do with that? I'm not a spy. This is past the age of spies. All right, data. This is actually a diagram I created in 2003. But we're finally approaching this kind of concept now. We are moving from a world of internet as documents, a world of documentation as documents, to a world of data. This may already be familiar to you, but note that the data is both distributed and dynamic. And I use the example of a person in a book there. That's me like 10 years ago. It's so much better than that. You know, and think about where the data about me is located. I have my credit card information, which is at the credit bureau. They laugh. My driver's license at the driver's bureau. My passport with the passport bureau. My non-existent criminal record at the criminal record bureau, etc. Right? Data about me is all over the place. Same with a book, right? There's information about the reader, about the Amazon listing, content ratings, etc. Now, the idea here is that the information about me or the information about the book or the information about anything isn't located in one canonical location anymore. It's distributed. And this data is linked to other elements of data, and you get kind of a graph-looking thing like that. I used to call them, and I still call them, first party, second party, third party metadata. That's when we all did metadata. But the main idea here is it's distributed and it's dynamic. It changes all the time. That thing records my age, and my age is not static, sadly but true. So Web 3 and e-learning 3 is based on the linked open data cloud. That's a mouthful. People like Tim Berners-Lee are working on it with a project called Solid. There's linked data protocols. There's I've got a link there to the WC3 wiki on linked data, etc. Over time, and you know, this began with the semantic web, people have been creating different databases and different data about different topics linked to each other. And so that's what's being built now behind the scenes. There are government projects. Canadian government has an open data project. Europe has open data projects. So this is becoming part of the background environment in which we're all working. It's not mainstream yet. This is all not mainstream yet, but it's coming into play. It's there. It's real and it exists. So right away, our approach to learning has to change. It has to change because it's really stupid to think of learning as remembering when what we're being presented as learning material is data, especially data that changes. I can't even keep track of the planets, let alone countries, capitals, etc. The data changes. The key skill, if you will, that we'll be looking for in the future as far as learning is concerned is getting to grips with the idea of knowledge as pattern recognition. I've got a simple thing here. It's a Wordle based on the idea of knowledge as pattern recognition. I love recursion. And the idea here is that you can see the representation of the data. You can recognize the patterns there. Some things stand out to you. It's supported by tools, by software, in this case, an application called Wordle. But the idea here is you go from data to application to recognition to knowledge. Make sense? It's a simple stroke so far, right? Okay. This part you're also familiar with, or you should be if you're not. Cloud. This is the era of the cloud. It's the beginning of the era of the cloud, although it's been going for a while. We have Amazon Web Services, Microsoft Azure, IBM, I think it's called BlueSphere or something stupid like that. I just left it. So Google Cloud, Alibaba, and there are others. DigitalOcean is the one that's the flavor of the day. They're always available, and they're not just places where you store your data. They're places where you store applications and services, interact with other applications and services. You can build websites or services that are scalable, that grow on demand, that you can add new services to as the demand exists. And most importantly, you can afford them. I can afford them. And if I can afford them, well, that's saying something, right? You don't have to be a big company in order to develop and deploy in the cloud anymore. And the tools now are available to do that. They're maturing. I've got Docker running on this computer. I can upload a container, a self-contained computer operating system, database, and program if I wanted to do it that way. I could upload that with a single command from my computer to the cloud and run it. And I could do it in about the time it took me to say that. I can get predefined Docker containers that I download to my computer, maybe customize as I wish, and then upload them. I can run the same container on Amazon Web Service or DigitalOcean or whatever. So, and then there's a whole alphabet soup of programs and platforms that allow you to stage and orchestrate all of these applications. I won't go into that. It's a whole separate talk, deep geek speak. But the main point to keep in mind is it's there and it's virtually automatic now. The people who are working in your computer services departments, they know about this. They're not telling you about this because that's their secret, but they know about this. They can deploy a functioning website in about 10 minutes with everything. Well, what does that do? One thing it does is it lets us create new kinds of learning resources. This is something called Jupyter Notebook. Now, I wouldn't just run Jupyter Notebook on my computer. I could, but it's a pain. So I put a Python server into a Docker box, and then I run Jupyter on that, and then access that using my browser. So I use a browser to access a program that's running on my own computer. That's actually the easy way, because I don't have to think about it, right? I just start up the container, start up my browser, I'm into Jupyter Notebook. Jupyter Notebook, meanwhile, is a mixture of content and computer code. This is an actual Jupyter Notebook. You'll see some text at the top, a mathematical function there that I don't really understand because it's got squiggles in it. Then some computer code underneath, and then some diagrams. The diagrams are the visual representation or the visual output of the computer code. Okay, yeah, well, we've all seen that. But what the reader can do is edit the programming language live and change the output. So what you have is a resource that you can run on your own desktop that is a functioning program that you can rewrite on the fly and see the result. That creates a link between the concept, the code, and the output, and it's right there in front of you. This is a new kind of learning resource. This isn't, a video or some text or even a conference. This is an actual live thing that you're working with in real time that you can control. Jupyter Notebooks and things like that are at least part of the future of learning resources. It becomes sort of silly to, if you're, say, teaching anything scientific, mathematical, even artistic. You can have things like this for music, for example, where you have the code for your music, and instead of pictures, you just press the play button and ding, 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 just changes our idea of web resources, learning resources entirely. What it does is, and this is really significant because this hasn't really happened before, except for work on the job, practicing with hammers in your hands. It puts creating and learning, code and outcome combined in a single environment, and that makes things very powerful. What was this here? This is Bloomberg. Paul Ford, what is code? So this is Paul Ford explaining what code is with examples of code and the output of code. Again, same sort of thing. Change the parameters, change the output. There's a bunch of things like that already, CodePen and things like that on the internet. This is becoming mainstream. So that's cloud. That's 2 of 9. It's going fast, isn't it? Graphs. Now, I've been talking about graphs forever, and so have a lot of people. But graphs are coming into their own as, if you will, the conceptual basis for what's being called Web 3. I didn't make up Web 3. If you look up Web 3, you'll find JavaScript code related to that, and that concept being talked about a lot by developers behind the scenes, and it's based on the idea of graph. You may have heard of the Facebook graph. This is the Microsoft graph. Again, it's based on the idea of linked data, but it's also based on the properties of graphs. We're going to explore some of those properties in a bit, but the idea here is we're now finally taking advantage of the properties of graphs in a way that we weren't before. So what's changed? Well, the way we used to think of graphs was semantically. For example, you probably have all heard of the semantic web. And the way that worked is you'd have one thing linked to another thing according to the data in that thing. So you'd have a person and the person's address linked to a location and the address of that location, right? Or a person and a company, so the person's related to the company by the name of the company. Things like web of trust, also built on the same sort of idea. We're connecting bits of content together. But now what's happening is we're transitioning from, and I tried to find a pithy phrase that would fit in here. So I said, from semantics to cryptography. Might not be the right way to phrase it exactly, but it'll do for now. And besides, I have an example. The example is something called a Merkle tree. Now again, whole presentation. But you see these things that are linked together, right? They are linked together by hashes of the content. Okay, kind of a hard concept. So let's look at this a little bit more. Is it 2 slides down? I can't tell. Well, I'll leave it there for now. So here's a data block. If I encode this data block, I create what's called a hash. And now I connect to this data block up here based on that hash. If I encode these 2 hashes, I create a new hash, there it is up there. So I'm using the hashes, the cryptographic encoding of the data, in order to connect the data together. That's your 1 minute explanation of Merkle graphs. And for those of you who are knowledgeable, I'm sorry. But it's close. So, okay, that's the concept. And there's another picture of it a bit further down. One of the things that Merkle graphs are being used for is something called the directed acyclic graph, or DAG, as in dagnammit. Okay, fell flat. Now, comedy is about you try something, and if people laugh, you keep it in the act, and if people don't laugh, it's gone. That one's gone. I love comedy. So a directed acyclic graph is exactly as it sounds. What do I mean by that? Well, directed means it's arrows, and the arrows go in a single direction. Acyclic means it's not cyclic, which means they don't loop back. So it's always moving forward. You never link or loop back to where you were. So you might think, how is this useful? Well, this is used to create collections of related data elements or related resources. And you might think, how is that useful? Well, here's a little site called GitHub. GitHub is probably the world's largest storehouse of open source software in the world. You might have read recently that Microsoft bought it for what, $2 billion or something like that. GitHub is based on a DAG, and in fact based on Merkle trees. And all of the source code provisioning, versioning, staging, committing, etc. is based on that graph methodology. Microsoft wasn't buying access to developers, although that's how it was represented. Microsoft was buying access to technology, and specifically the world's largest functioning DAG. Smart, so smart. So think about how this might change what we're up to if we had access to that. I have a couple ideas in some of the sections that follow, but this now is going to be the foundation of our new World Wide Web. Okay, let's change tracks a wee bit and jump to identity. Because there is no real order, right? You want this to be in a nice linear thing, but I can't. All of these are interrelated concepts. There isn't a nice, single, neat way of doing it. So I'll jump to identity. And as you probably read, in social networks, we were the product, right? How did that saying go? If you're not paying for it, you are the product, something like that. Anyhow, our identity, our buying habits, our preferences, everything about us is it still true, is the product that Facebook is selling to its advertisers and other marketers. Same with every other site out there that's free. Same with newspapers, and it's really messed them up in ways that we could talk about for another whole session. Even learning management systems, educational systems, student data is the product. They may make money by selling software, but I'm sure they are far more interested in the student data. That's why Turn Me In is a success. It's not like stopping exam cheating is such a big market. It's all that data. So what's happening? Our way of representing ourselves online is now due for a big change. The good news is it's an end to passwords. Everybody? Yeah, even better, an end to two-factor authentication, which is horrible, because two-factor authentication is only as secure as the weakest of the two factors when you think about it. So yeah, passwords don't work, haven't worked, and the worst thing about them is that when you log onto a website, then you're giving them information about yourself, like your email address and your name, etc. It's never just a password, is it? I've never seen just a password on a website. So what we're getting instead is asymmetric encryption, or two-key access. So passwords, even two-factor authentication, is symmetric encryption, right? You have a coded password. Asymmetric encryption is you have two keys that work together to create a single identity. You have a private key that you keep to yourself, and then a public key. Doesn't matter if people have it. In fact, you need to share it. So, oh, am I missing part of my slide, or does that come later? So our access will be maintained. Can you tell this is new content, right? Because I sometimes forget how it goes. So what we will use in order to manage our access is our private key. But our private key isn't going to be an 8-character password. It's going to be something like a 128-bit string, or 128-byte string that we cannot remember. And nobody would want to remember it. And so this private key will be kept either securely on our own computer in a private key file, or even better, it'll be kept, I was going to bring mine, but I forgot it, kept on a physical device. And so you just plug your physical device into the computer, and that's how you will authenticate to get onto websites in the future. You might ask, well, what happens if you lose your physical device? Google is releasing, what did they call it? Unity? Something like that, which is actually two physical devices. One, which you use to access your computer. A second one, which you use, put it in your desk drawer and forget about it. But when you lose the first one, because you will lose the first one, you use the second one to create a new first one. So that's pretty smart. So now it's a lot harder for all of these sites to track us and to collect all of our data. And so what becomes of our identity if it's not something that's bought and sold? Well, it's the thread, the personally identifiable thread that runs through an otherwise disconnected set of data. All these random facts that are out there in the world, an age, a driver's license, a health record, etc. My personal identity is the thing that connects them all, but I'm the one who's in control of my personal identity, and therefore access to and the capacity to associate all of these discrete bits of data. It's a messy concept, but in practice, it boils down to you identify yourself with your key, you put your key into the computer, and that keeps your identity more secure, not 100% secure, but more secure than it has been in the past. Pragmatically, it means that the quantified self that has characterized things like learning analytics, big data, testing, etc., is going to give way to a qualified self and ultimately to a connected self. We're not going to be measured by our numbers in the future. We will measure ourselves, and we'll measure ourselves more by our properties, our affinities, the things we've done, the things that we've created, rather than, say, test grades or distance traveled or whatever. Kind of a hard concept, and I still don't have my mind completely wrapped around it, but something like that is where it's going. Resources. So, the web was once open. You might not remember that, but I do, because I'm old. There were things like email and websites, even before passwords. There was something called Usenet, and that's a diagram of it, which just was a widely shared messaging platform that anybody could access till it was bought by Yahoo and privatized and basically destroyed. Today, you need to sign your password to get into Facebook. LinkedIn is terrible. LinkedIn doesn't want you to see anything unless you sign. You gotta sign in to see everything. It's a closed web. It's not simply a web of platforms. It's a web of data with barriers on it. And people are beginning to react against this. I mean, there was the S-plan in Britain, not in Britain, in Europe, which is not Britain, to ensure that all publicly funded research is openly available. So cool. Publishers hate that, but cool. And other open access initiatives. It's been a thing for a while. But still, you know, as a political campaign, it can only be as effective as the politics. And a lot of people are looking at this and saying, you know, we can't depend on the politics to keep the web open. There's lots of counterexamples, the whole net neutrality debate thing, for example, or copyright. If you read Michael Geist and his analysis of copyright in the Son of NAFTA, you know, you can't depend on policy. So Web 3, as it's being called, not made up by me, is a large degree a reaction to this. What I have illustrated here is something called the interplanetary file system. I love the name, although I know it's a little bit out there. And related to that interplanetary linked data, and come around full circle, right? If you look really closely, it's kind of hard to see, but you see something very similar to GitHub, very similar to DAGs, very similar to Merkle trees and Merkle graphs. What you have here is essentially, and it's a bit loose to call it this, but I will, content addressable networking. Interplanetary file system is very interesting. Take some content, War and Peace. Take that content and run it through a hashing algorithm, a good hashing algorithm. There's a bunch of them. So pick a good one, SHA-2 or something. Although I don't know if that's good anymore. And never mind. Run it through and you get a fixed length string of basically random characters. Right? Well, they're not random though. That's called the hash of War and Peace. One of the advantages of that hash is it's a lot shorter than War and Peace, right? The other thing is if you make these strings long enough, then it's pretty much knowably unique to War and Peace. That hash will be generated by War and Peace and only War and Peace. And even more significantly, if you change one comma in War and Peace, anywhere, page 134 said, you change the hash. And quite dramatically, right? And you can't determine, if you look at two hashes, you can't tell they're from the same thing. So that's what you do. The interplanetary file system, you upload some content, but by uploading it, what you're doing is you make a hash of it. And then you give that content to every other node, or you make it available to every other node in the file system. The interplanetary file system is made up of individual nodes spread out around the world. I don't know how many there are, but there's lots. And they might not get all of War and Peace because that's a lot. So, you know, one site might have chapter 1, another site might have chapter 2, another site might have chapter 3. So you'll build up War and Peace through a Merkle tree. That's fine. But the main thing here is, to simplify it, is you have this hash that you can use now as the address of War and Peace. You don't care where it's stored. In fact, it's stored in pieces all over the place. All you're doing is you're looking for this hash. You put in a request to the file system for this hash. The file system looks to find the closest place where War and Peace is actually located and delivers it to you. Well, that's pretty cool. Doesn't matter where it was. But what if somebody puts a virus in it? But they can't, because you used the hash, which is a Merkle tree, so it's hashes all the way down, so that if they change 1 comma, it won't match the address anymore. So when you receive the content from the file system, you run the content through the same encryption algorithm, and those outputs must match. If they don't match, you discard it, somebody's messed with it. So you have content security. That's how it works. Now, there's a lot of, squiggles underneath that to make it work, but it's a new way of distributing and accessing data. And it's not even Bitcoin. So here's the slide about content addressable networking that I should have put earlier. So here's the data. Here's the hash function. This is the hash, they're calling it a key here, that was produced. You can see it's different. It's Fox. The Fox runs across the ice. The Fox walks across the ice. It's different for each version of the content. And you throw it into this distributed network. If you want this sentence, ask for this. If you want this sentence, ask for this. So that's all it is. That's all it is. The actual encryption function is I saw the video is like the encryption functions explained at 5 levels of difficulty, where they go from, oh yeah, no, you just move the words around, to no, you use this kind of modulus mathematics. So I introduced to you for the first time in public. You heard it here first because it's never been announced before. The content addressable resources for education, or CARE. This is the new version of open educational resources. We use a system exactly like this, exactly like IPFS. And we set it up so you can see it now, right? So IPFS, the educational IPFS is called CareNet. And collected resources that we might want to say associate together as a course, they are called, are you ready for it? Care packages. So I was intending to actually create the very first care package at this talk, but I just ran out of time. But I will create it during the course of the course, and it'll all be documented. Think about it now. All the arguments people have been having about open educational resources and licensing, all of that is gone. We don't need any of that anymore. All we need to do is create a resource, put it in CareNet, it's accessible to everybody. Sustainability, what's sustainability? The sustainability of the network is created by the people using the network. Each person contributes a small share. CareNet, you heard it here first. Recognition. So I've been talking about learning, e-learning 3.0, graphs, peers, identity, all that crap. Sorry. What counts as success in e-learning? It's not remembering, remember? It's recognition. So what does that mean? Competencies? Is it competencies? There's been all kinds of work being done in competencies, whether you're in traditional university, K-12, corporate learning, you've been overwhelmed with competencies. I've got lots of issues with competencies, but I don't need to go into those issues with competencies because we'll replace them because it's easier. But you keep in mind what a competency is, right? It's a detailed description of what it takes to accomplish a task or a function or instantiate a skill, along with the evidence needed in order to prove, and possibly a certificate or badge representing that proof. It's a short version of competencies. And the technology that's been built up behind that is based on something called the Experience API. You may see some nods out there. You may recognize that. And it's a good concept in that it's data, right? So we're using data instead of documents to assess somebody's, well, competencies. So that's good. You know, and we can record activities of any sort, you know, assessments, quizzes, whatever. Did you watch a video? Did you go to the baseball game? Whatever. And it can be used to measure team performance or whatever. And it doesn't matter whether you use a mobile app or your desktop or some part of the Internet of Things. The whole idea is that this range of things can be collecting data about you and sending it in. But therein lies the problem. It sends it to a single centralized resource called a learning records store. And that's the old platform Internet again. So the XAPI system is basically a tracking and spying system. That's fine in some environments, but as a system that we're planning to deploy society-wide, it's probably got its weaknesses. It might work in a single corporation, but once the learning starts going outside the corporation, now we begin to get into issues of privacy, security, and trust. So, okay, what then? Well, recognition is something that also can be done by the individual. This is something from Yet, and Yet has a learning record store too. But what I liked about this is that it takes us back to this idea of data as something that we recognize, pattern recognition, all of that, except now it's data about ourselves, and we're recognizing our own performance. I already use stuff like that. I use Strava, for example, to record my cycling. Yes, I cycle. I know it doesn't look like it, but I do. And what's interesting about using Strava is it's my data, and I don't send it to my employer or my health insurance company, and I'm not going to, because we have public health care. I don't have to do that. But the thing is, now that we're in this whole concept of data, gathering data, etc., we don't need to use proxies like tests, assignments, essays, quizzes, etc. anymore. And in fact, why would we? Because the learning that we're doing, whether in corporate learning or university learning, isn't intended to be applied inside the learning environment. It's intended to be applied outside the learning environment, in the workplace, say, or with your own tools and your own resources for your hobbies or whatever. And that's where we will be gathering our data. You know, if you're in corporate learning, you're familiar with the Kirkpatrick levels, 1, 2, 3, 4, and sometimes 5, depending on who you ask. And you can go straight to level 4, but level 4 won't be based on interviews with management or anything like that. It goes straight to actual performance data, both on the part of the individual and the part of the organization. That becomes your form of recognition for the learning that has been done. So you don't need to do the test of the person. Did you learn this stuff? You do the test of the action after. Did you apply this stuff? Did it work? And I know it's a more complex system, and of course it raises questions of privacy and surveillance in that, but that's why it makes so much more sense to use a distributed network rather than a single centralized learning record store that can be bought and commercialized by Facebook. Community. Now we're getting into the fun stuff. Education's always been about community. It's always been about you know, groups of learners and all of that. Community, meanwhile, in the past, has always been about sameness. It's the origin of, you know, religion. Everybody believes the same thing. It's the origin of nationalism. Everybody lives in the same place, etc. Community, though, in our world, and especially in diverse societies like Canada, is no longer based on sameness. It's because sameness is being perceived as a weakness rather than a strength. So what is community now? Community now is based on making decisions together, or, if you will, in a word, consensus. A consensus is what creates community. Now, that's a controversial statement. Again, whole presentation on that, right? But there you go. So the big question is, how does the community create consensus? And that, I submit, is the issue of the day. Truth is where you begin with consensus, but where do you get truth from? Simon Blackburn says, and I agree, each person is able to identify their truth for themselves. At a certain level, people are pretty comfortable with knowing whether or not something is true. I'll give you an example. This is a white cup. Everyone with me? All right? Mostly white. Maybe we could qualify it a bit. Does it count as a cup? Does it have to have a lid? If it has a lid, is it really a glass and not a cup? Whatever. And we'll leave those arguments for the philosophers, and the philosophers will have them, trust me. But for day-to-day practical purposes, we can live with that as a cup. And we, as a group here, can agree, more or less, that that is a cup. And we've derived consensus, and now we are a cup-based community. In the real world, it's harder than that. There's a thing called the Byzantine generals problem. The Byzantine generals problem works like this. You have the Byzantine emperor, who has a very large empire, and so he needs to have a bunch of generals to maintain order and conquer new lands and defend against, the infidel or whatever. His generals sometimes want to overthrow the emperor. So you have what you call bad actors, right? So, and it's a pretty distributed communications network. How do you set up consensus in an environment where some of the generals want to take you down? That's the Byzantine general problem. Because you don't know which one is lying to you. You don't know which one is going to lead you into a trap and have you slaughtered and take your throne. It's a very messy problem. That is the problem being faced in society today. We have what might be called bad actors in our networks, Byzantine generals, who want to take the system down. Some of them want to take it over. Some of them just want to see it burn. It doesn't matter. So the really neat thing about blockchain and Bitcoin is that it addressed square on the Byzantine generals problem. So there are different consensus algorithms that they've developed over the course of the last 5 years or so. These are some of them. The famous one, Bitcoin itself, is called proof of work, which is a pretty effective mechanism, except that it takes the energy production of a medium-sized country in order to make it work. It's also really slow. So there's proof of stake. That's kind of like your poker game, right? Where you put in your money and you have a stake in the game. Proof of importance, proof of concept, proof of authority, which is a system that some of the banks and financial institutions are putting their money on. You have only a certain number of people are allowed to be generals or participants in the consensus. But that leads us back into centralism, and we want decentralism. This isn't worked out yet. It's going to be worked out. It's going to be worked out because there is one solution that we know does work. It's just really inefficient. And that's the proof of work. And Bitcoin is based on it. Ethereum is based on it. And you can create other solutions, they call them second level solutions, based around the proof of work mechanism that kind of work. So these mechanisms are really important. And being able to access and use these mechanisms are really important. So in terms of education, what we need in order to enable ourselves to function in this kind of environment is to be able to be good consensus makers and good decision makers, to be able to navigate this web of consensus. This is some of my own work here where I've identified what I call the critical literacies. I won't go into them in detail, but there is a link there. But basically, syntax, being able to do pattern recognition; semantics, being able to assign the meaning, importance, and value of something; context, being able to identify something in relation to its environment; use, cognition, inference, like deduction, induction, inference to the best explanation, definition; and then finally change, processes of change, regression, cyclic change, etc. Those are the bases for being able to function as informed citizens in a consensus-based network. So capacity in this will replace, to a certain degree, learning that is based on knowledge acquisition and remembering of content. Community. This is how we begin, or sorry, experience. This is how we begin to bring this together. We learn from experience. You knew that was a white cup because you saw it was a white cup, except for those of you in the hall who had to take my word for it. We learn from experience. We learn from reflecting on experience. Back to Dewey. What we're beginning to do now with these new systems is to combine the experience and the reflection. The experience of something and the reflecting on something are both part of the same activity, the same environment, the same thing. Let me give you an example, and you might be a bit surprised by that example. Fortnite. The way Fortnite works is 100 players enter, 1 player leaves, right? It's a battle royale. That's one of the models of Fortnite. But the thing is, when you get killed in Fortnite, you don't leave the game. You get to stay in the game and watch the game. So in an instant, you're converted from participant to spectator. And we're seeing this all over the web. Spend any time on YouTube, it's not just gaming. There's a range of things happening out there where people are at the same time participant and spectator. The whole electronic music scene, for example, is a good example of that. A lot of art sites, video making, hobbyist sites, a lot of the reality television shows that we see, like, Forged in Fire and that, are outgrowths of these YouTube videos where people were doing it for themselves. Creation is becoming part of the content itself. There isn't a distinction to be drawn between learning content and working with content. Learning content and working with content become one and the same thing in this environment. You're creating data while working data with data while learning that data, or at least learning how to recognize and work with that data. It's pretty circular, I know, but and so this here, for example, is video streaming equipment, and so here we have an example of me creating content by video streaming, which I really hope is still working. The content is the act of creating the content. We were talking before this session, why aren't all of our conference sessions like this? Why aren't all of our learning experiences like this? Why on earth would we think of learning as something that's done entirely and only by people in a small room? There's a whole world of literature devoted to the concept of working openly and learning openly. And in a distributed data network, that's the model that tends to prevail. Indeed, workplaces themselves are beginning to reorganize along those lines. They're beginning to reorganize, as it says here, to create self-organizing, consensus-based co-production networks. There are some examples. Steam is an example I can think of off the top of my head. This is a reference to an article in Science Direct about the safety management system, co-managed safety management system in an organization. That's how it'll work, how it does work in a lot of organizations now, right? You don't convert the entire organization at once, that would be madness. But you convert essential, or you convert subsystems of the organization, one after another and after another. Gradually you deploy, so safety is a natural, right? Everybody has an interest in safety, but ultimately everyone will have an interest in profit too. Finally, agency, which I realized I defined by accident, the relative standing of the individual with respect to community, institutions, and governments. Agency changes as technology changes. And what that means is all of these changes that are happening to the web, to e-learning, change our conception of agency itself. From my perspective, looking at the web and looking at agency in different societies, there's going to be 4 key elements of this new technological framework: security, identity, voice, and opportunity. And I expand on that in a paper that I called What Peace Means to Me, because peace, consensus, and society are based on these 4 elements. And so that brings us toward the conclusion of this talk. Education, this new kind of education, no matter where it's taking place, has to focus on the capacities for agency, has to focus on the capacities for security, identity, voice, and opportunity. And it's not, the individual versus the state. It's the individual in a society where the society is individuals coming to conclusions, making decisions about that society for themselves. And this photograph is taken by my niece. Lorelei, thank you very much. Technically, I've got 2 minutes for questions.
Fred, can you go back to the slide that defined agency? Thank you.
Yeah, I wrote that. I didn't intend to define it, but I look at it and it seems like a pretty good definition, although, again, the philosophers will complain.
Yeah. So is that a trick which an individual can do at their house, or do it in institutions, or anywhere?
I'll go with anywhere. Do you mean the course, or do you mean just e-learning 3.0 in general?
E-learning 3.0. Yeah.
I'd say anyone. The tools are within your grasp. There's a learning curve, right? You need to learn to make Docker boxes or things like that. But you can start just by looking for Jupyter notebooks and playing with them for a while. You can play Fortnite. But more to the point, I would say learn the technologies of creating openly. Learn how to webcast and then do it, for example. And once you start doing that, then the other elements will begin to layer on itself. The question in the back?
So in this new world with critical literacies of pattern recognition, context, use, cognitive inference, is that going to help us with our problem of truthiness? Or give us your philosophical view, because we've been very technical here. I want to hear where we're going to be 5 to 10 years from now with our unintended consequences.
Yeah, I get you. Yeah, the question was, is all of this going to help with our problem of truthiness? And my answer to that is, truthiness is a consensus problem, in a technical sense as well as a philosophical sense. The problem isn't that there are people who are bad actors out there. I mean, it's a problem, but it's not something we can do anything about, right? Without incredibly repressive means, and even then that probably wouldn't work. There's always going to be people who are trying to subvert the system for their own gain. So the problem is making the system resilient to them. And right now, the system is not resilient. And the evidence for that is how easily they can subvert platform-based systems like Facebook and Twitter for their own ends. It doesn't matter who they are, right? Radical left, radical right, who cares, right? What they've done is broken our capacity to reach a consensus. So what we need is a platform that is, well, not a platform, but a system of decision-making which is resistant to that. I don't say we'll prevent that, but which is resistant to that. And the argument that I have, and I've had for a long time, is that system is going to be decentralized. It is going to be decentralized because the way the bad actors take down the system is they take down the center. Or at the very least, they cast doubt about the center. They cast doubt about what is the center, what is the source of truth, who do you trust, right? In a decentralized system, trust is something that each person manages for themselves and manages for their own set of individuals that they're in connection with, using Dunbar's number as a rough estimate of about 150 people. Once you have that, you have a system that you can't subvert simply by seeding an idea to an influencer and having it spread by robots or whatever. You have to go person to person. Each person applies their cup test to that idea. And in that case, the ideas that tend to propagate are ideas that tend to be consistent with the individual experience of all of the people. That's my answer, all right? I'm pretty sure it works. I'm pretty sure it works because there's mathematics of graph theory behind it. I'm pretty sure it works because that's the sort of approach that they take to epidemiology, for example, in trying to make society more resistant to the disease, to the spread of a disease. They don't go after everybody individually. They don't even go after the most severe cases. They go after the central nodes, the people who are most likely to transmit, the typhoid Marys. And so they don't need to eliminate the disease, they just need to eliminate the centralized spreading of the disease. So that's why I think it'll work. Will there be other unintended consequences? Oh yeah, we're people. But there'll be new unintended consequences, and we'll deal with them in the next round of development. And I'm getting the time signal from the back, so thank you so much for coming. And I'll see you next year. Tonight's everyone. Sorry the back channel didn't work. Next week. And I hope the video works. And now I'm going to sign out. Bye. We had six